So this is a supplementary video to the earlier one on solving quadratic equations, and you'll be pleased to hear that this one is going to make your life a lot simpler. So previously the two methods that we used were completing the square on the left here, where we took the equation x squared plus x equal to 6. We took the idea of completing the square, which is laid out here, and we solved that equation using this grid here, completing the square and then arriving at x equals 2 or x equals minus 3. And that worked fine, and it's fairly straightforward to do. Our second method was to use the quadratic formula, and we also looked at why it was that this quadratic formula works. It's simply a rearrangement of the standard form, which I'll write out here quickly. The standard form of a quadratic equation, which is this. Ax squared plus bx plus c equal to 0. So what we're doing in this method is we're making that x squared plus x equals 6 equation equal to 0 by subtracting 6 from both sides, and then we're plugging in those values into our formula, which has been rearranged from the standard form into this useful form, and then we end up with the same answers, x equals 2 and x equals minus 3. So two answers to this quadratic equation. Now, I said I'm going to make your life easier, and this is how we do it. This time, and I'll keep to this coloured ink so we can see it's a different method, we're going to use factoring. Now, we learnt about factoring in a previous video. We start with the standard form, so x squared plus x minus 6 equal to 0. But what we're going to do to the left-hand side now is factorize it. In other words, find two binomials that multiply together will give us x squared plus x minus 6. And there was another video that went through this very, very carefully and showed you different ways of doing it. One of the very effective ways of doing it, and pretty quick to do, let's just use a different colour ink. Yeah, let's just use a lighter blue, is to use what's called product and sum. So if I put a little skeletal x here to work in, you can see how this works. All I do is I take that middle term there, which is 1. I use the coefficient of 1, so it's just 1x, so I put 1 there. And I take my product, which is the coefficient of the x squared, 1 times the minus 6, so minus 6. And what I'm doing here, if I just sketch this out here, is I'm looking for 4 terms, because my factors, my two factors in brackets are going to be 4 terms in total, so I'll need to split this middle term, this x term, into 2. Well, I know that the first term is x squared, I know the last is minus 6, but what I don't know is how this splits. So this working out is to work out how this x term is going to split. So if I go back to this, I know that I need it to add to 1x, and I take my product, the minus 6, and I say, well, what about minus 1 times 6? So minus 1 times 6 will give me minus 6, but 6 plus minus 1, or 6 minus 1, will not give me 1, so that won't work. Then I try 2 and 3, because minus 2 times 3 will give me minus 6. And there I've got it. Minus 2 plus 3 will also give me 1. So I know that my x term is going to be minus 2x plus 3x, like that. Why is this really good? Because it then very easily allows me to, to find these this pair of factors, because x squared must have been made from x times x, so we're looking at the lengths either side of this rectangle now, and the 3x must have come from 3 times x, so now I've got my first factor, my first binomial, x plus 3, and here Well, I could do it a couple of ways, but if I look at minus 2 times x times something gives me minus 2, then this must be minus 2 along this side here. So it's these two sides that multiplied together will give me these internal terms, the product of these two things. So now I can factorize the expression. Just as a double check, minus 2 times 3 does give me that minus 6, so this little working out is correct. So what it means is I can now rewrite this x plus 3 times x minus 2 equals 0, and proceed from there. Now, what we're dealing with now is something known as the zero product property. What's the zero product property? Well, basically it says something fairly obvious if you think about it, that one of these terms, at least one of these terms, or in fact, or both of these terms, must equal 0. Because the only time you multiply a term or any number and get 0 is when you're multiplying by 0. In other words, I've got two possibilities here. I might have x plus 3 equaling 0, in which case x must equal, or subtract 3 from both sides, minus 3. So there's my first answer, x minus 3, but this time derived by factorisation. But the other possibility is that x minus 2 might be the one that equals 0. So the other possibility sees that I've got x minus 2 equal to 0. Therefore, x, well, add 2 to both sides, x must equal plus 2, so 2. So that's solving a quadratic expression, a quadratic equation by factorising. I'm just going to show you a slight variation of this though, because very often you don't even need to go to those lengths to solve something like this. So the other method would be, here I am in the middle of a calculation, I now need to solve x squared plus x minus 6 equal to 0. A good method, and one that very often people simply use, and the quickest method, is if you've got something like this, just use logical deduction. Now, people call this trial and error, but there's nothing wrong with that as long as it works. And with this method, we're very quickly going to be able to check we've got the right answer by multiplying out. So try it. If it doesn't work, nothing lost. Go to one of these more technical methods, but always try the simpler route first. So what this says is, well, I know, because I've got no coefficient of x here, that both of my terms must be x. Okay, so I can put those in straight away. I also know that if I've got minus 6 here, but there's a plus term in the middle, then I must have one of these terms must be a plus and the other one has to be a minus. If they were both minus, then I'd end up with a positive constant at the end. If they were both plus, I would end up with a positive constant at the end. So by logical reasoning, it must be a plus or minus. And look, I've now nearly finished factorising. All I need to do is think of some terms that will go in here. Well, I know that I've got to sum to 1, and I know that I've got to have a positive times a negative giving me minus 6. Well, there are only so many ways of doing that, and it should be fairly straightforward to just think, well, let's try 3. Okay? Let's try 3. Or, say you got it wrong, let's try 2. Okay? Let's try 2. Now, x plus 2 times what? Well, 2 times 3 will give me minus 6. The only problem here is I've got 2x, if I use foiling here, so I've got 2x minus 3x, which will give me a negative x. So two ways I can go here. The first is I can change around the symbols, okay, or I can change around the numbers. This time I'll change around the symbols. So perhaps I just use a pencil. Okay. Either way, it's very quick and easy with a lot of these quadratic equations to just work with a sort of trial and error method, logical reasoning, and get to that answer much quicker. And examiners will be perfectly happy with that because they'll be used to you working in this way. So what have I done? All I've done, after all, is rearrange this form. I've just factorized it. I haven't changed anything. I've just restated it in factorized form. And now, again, I can give my answer x must be. Now, again, I could lay it out like this, but most of us know that the shortcut is to say x minus 2 equals 0. Well, x must equal 2. And all I'm doing there is changing the sign. So when I see these brackets here, I see a negative, I simply say, well, x must equal 2. And, or x equals, change that sign, equals minus 3. So there we are. That's really completed this tutorial on quadratic equations. You can see there are so many different ways of doing it. Now, it's very important to say you ought to know how to do all of these things because they all have their different uses. It's particularly important to be able to complete the square because that's a way of finding out so many other things. And you also ought to be able to use this method. Using the quadratic formula. Again, because the quadratic formula has so many uses, can be broken up and used in so many different ways. But for everyday factorizing or factoring, then using either this method until you're quite confident, but then this method where you're just going straight for the factors that you can almost see straight away, well then that's perfectly fine. And the skill basically that you need to develop. Right, so here is the sort of situation where you might want to just use a quick factorizing method. So what have we got here? We've got x squared plus 2x here and x here, so that's 3x, and we've got 2 1s. So in other words, we've got x squared plus 3x plus 2. And clearly that factorizes. We can see from these algebra tiles that we're going to easily get x plus 2 and x plus 1 on both sides. Can we see that though if we just look at it and work things out? Well, let's move it over to one side here and see if we can work this one out. So we've got x squared plus 3x plus 2. And we're just going to do it by putting the brackets in straight away and using logical reasoning. So we put our x in here to start with. We know it's plus, so we're going to have 2 plus signs, and all we've got to do is look at this final term here, 1 times 2, because we've got a 1 on the front here, so we've got just 2. 2 and 1, doesn't matter where we put them, very easily factorized to become x plus 2 times x plus 1. So situations like that, we certainly wouldn't want to bother with the quadratic equation or with completing the square. We can go straight ahead and find those factors. Let's try this one. Now we've got x squared, we've got 2x squareds, we've got 3. Let's just change this a little. Can we change it? There we go. Let's change that as well. That's fine. Okay. So now we've got minus x. It's going to be a little trickier this, I guess. 2x squared minus 2x plus x gives us our minus 1 here. So let's write it out. We've got 2x squareds plus x minus 2x, but that's going to mean that split is going to be disguised. So we've got just minus x once we've cancelled those out, and then minus 1. So there we go. There's our expression that we're now going to try and factorize without using any of the more sophisticated methods. Let's see if it will work. Let's call this A and this one B. Okay, A, oops. There we go. Let's just erase that. Okay. So A, B, and we'll do this one in a moment, C. So for B, what have we got? 2x squared minus x minus 1. Well, again, we can just put in our brackets to start with. We can say, well, it can only be 2x and x. So not too tricky here. We've got minus 1 that we've got to make, 2 times minus 1. Okay, and it's got to be minus x in the middle. So there are only so many ways of doing this. It's a little trickier to work out, but maybe what we want to do is start with this final term. So we know we've got to have 2 times, well, it's got to be 2 times 1, and so it's got to be minus 1 here, and one of these has got to be a plus. So we just try things like that. So that's going to give us minus 2x, plus 2x minus x. That's not going to work because that's going to give us a positive x in the middle. Our minus 1 times our plus 1 is going to give us our minus 1, but we've got a positive in the middle. So all we need to do is swap these signs like this, and we've now got we now have the positive there and the negative there. Multiply it out, see if it works. 2x squared minus 2x plus x minus 1. So not too difficult, but we're going to finally try with this one and see whether that's any harder. So we've got x squared, x squared, x squared. These are all representing minus x, minus x, minus x. This is minus 1 then. So 4 of those, and we've got 3 x's here. So what's going to happen is when these combine, we're going to end up with 3x squared minus 4x plus 3x, in other words, minus x minus 4. Okay, so there, the middle term is the thing that we need to unravel. Let's try it. Okay, so we've got 3x squared minus x minus 4 now, and we're going to try putting it in brackets. Now, it should be said that if this term gets any larger, the 3x becomes 4x squared, for example, the 3x squared becomes 4x squared, then we're going to have more options. More variety means more complication, and that's when we work on those standard methods that I showed you. But in this case, 3x has to go in one bracket and x in the other, so it's going to be like that. We've then got a negative here and a negative in the middle, so we must have a positive and a negative. But we don't know quite how we're going to get to that point. So let's just try a positive here and a negative here, and then see what we can do at the end. Well, we know these two ordinary numbers at the end of each of the binomials is going to multiply to minus 4, but we've got, see, this is trickier because we need 3 times something. Let's try 3 times 1. Okay, and now we know that this has got to be 4. So we've got 4 times minus 1, that's going to give us our minus 4. We've got our 3x squared, but does the middle work? Well, we've got 4x minus 3x. So that one's not going to work. So we'll have to have another variation. I'm going to leave that in this case and just, no, I won't, I'll erase it. But what we can do when we're not ordinarily working this out is try it on different rows. Just put a cross next to it. Okay, let's try again. So this time we've got our 3x there. Again, a lot of knowns. We do know that we've got 3x and x in the bracket. We also know that we've got to have a plus and a minus, but this time let's try a minus here and a plus here. We have to have a 1 here, so that's going to give us our 3x, and we've got to have a 4 here to give us our minus 4. Let's see if this works out. 3x squared plus 3x minus 4x gives us our minus x in the middle, and then minus 4 times 1 gives us our 4. So by logical reasoning we got to the right result. Okay, but you can see how this is going to get more complicated, and although this method is worth trying, is worth giving a go, if it takes any longer than it took here, then clearly you should be going for a standard method, which doesn't take that much longer anyway. Okay.